Hi, in this video, I want to show you how to graph piecewise defined function. Okay, so but let's look at this. How do you write algebraically a piecewise defined function? So this is the way you write it. First, you want a name of the functions. Again, this is f of x. It doesn't mean f times x. Never, never. It's just a notation. So this is a name. So the name of a function. Okay, that's the name of the function. And then you have a single brace. So this is a single, you have a single brace or a fancy or curly parenthesis. Now, so this, the information right here, right, what you have right here represent the function, okay, the functions. And for my piecewise function, I had two functions. It can be more than two. Okay, it can be 3 or 4, okay, and then more. But for this, the purpose of the video, for this video, I'm only going to use 2, okay, 2 pieces of the function. And now, so now those 2 intervals represent the domain restriction. Okay, those 2 represent the domain. So why do you have a domain restriction? Now the lines of this function x can only be graphed or seen if the x value are less than or the line underneath equal to positive 2. So I can only graph the first function. So basically, you're going to see a piece of the function on different interval on the x-axis. Okay, so the first piece I want to graph is the function x. Where can I graph it? Only if the x value are greater, so are less than or equal to 2. So the arrow is pointing to the left. So I know it has to be less than or equal to positive 2. So let me place 2 here. And what I like to do, I like to draw my visual reminder line, okay, to let me know that the line that I'm going to graph cannot cross over this vertical line, but pass through the 2, x equal 2. Then what am I going to do then? Okay, so I'm going to use a highlighter. And we know that x cannot be, so I can only graph for x if the x value are less than or equal to 2. Where do we see, okay, on the number line, on the x-axis, where do you have the x value less or equal to 2? Is it going to be on the left side of positive 2 or on the right side of positive 2? So, no, I hope you can see it's going to be on the left side. Why? All those numbers on the left side of positive 2 are what? They are less than 2, okay? So then I'm going to use a color pencil, okay, so to make sure it's a visual one. So I'm going to color that region. Why? So again, it's a visual reminder. I'm doing all of this so you can see that visually, and I am a visual learner, but the line cannot cross over, the line of y equal x cannot cross over this region. So this function x, the graph of the function y equal x can only be here in that area, in that region. Okay, it cannot cross over to the line for x equal 2. Okay, so what am I going to do next? So remember, I hope you can remember that this is x. So all you want to do here, you want to graph the line y equal x. Okay, so what do we know about the slope? What is m equal to? So m equal to 1, and have you turn 1 as a fraction? You draw a line and you write 1 under, which means you're going to go up 1 and move to the right 1. And from where are you going to start? Remember, this is 1x, or 1 times x, plus one number is added to the x, is 0. So you're going to start at the origin. So I'm going to go to the origin, and what am I going to do? I'm going to go up 1 and move to the right 1. Then I place my dot. You go up 1 and move to the right 1. Then you place your dot. Okay, can I continue further? Again, this is my visual reminder, but I cannot cross over. Why? The line that I'm going to build can only be seen for x value that are less than or equal to 2. So the line can only exist in that region, on the left side of positive 2. So I am not allowed, I'm being restricted to this domain, the domain for all the x value less than 2, not greater than 2. Okay, so let's continue. So however, I want to build a line on the left side of the line. Okay, what do I do? Again, you go back to the y-intercept, which is at 0. And instead of going up 1 and going to the right 1, you're going to go backward. So I'm going to go down 1 and move to the left 1. Okay? Down 1 and move to the left 1. Down 1 and move to the left 1. Down 1 and move to the left 1. 1. Okay, I think I have enough order there. So I'm going to now use my ruler and connect the dot. And make sure you include the arrows. Now, the arrows can only be included on the left side, not on the right. Okay? So now, I have to find out 1x equal 2. Okay? Is it going to be a full dot or an empty dot? Because the x value can be equal to 2, so I know that my dot 1x equal 2 on the line, on the line of the function, is going to be a full dot. Okay? So now let's do the other one. So now I need to graph the function y equal negative x. So where am I going to graph it? It can only be seen for x value that are greater than positive 2. So I'm going to go on the x-axis. Remember, the number that are on the x-axis, the number that are greater than positive 2 are located on the right side of 2. So I'm going to highlight all the number on the right side of 2. Why? Because they are greater than 2. Okay? Like 10 is greater than 2. 20 is greater than 2. 3 is greater than 2. That's what I'm shading. I'm highlighting all the number on the right side of 2 on the x-axis. Then I'm going to use a different color. So I want to shade this region white to let you know that we cannot cross over again the visual reminder that the line can only be graphed in this region, right? For all the x values that are less than, sorry, greater than 2, not less than 2, greater than 2. So now let's look at this function here. So the function that we're going to graph is y equal negative x. Okay, so could I use f of x or y? It doesn't matter, it means the same thing, but this one needs to be the same. Okay. So the expression for the function needs to be the same. And what I have is negative x. So what is m? The slope of m. Okay, remember, there is a 1 in front in case you don't see, but because there's a negative in front, so my slope is negative 1. So how do we turn negative 1 as a fraction? You draw a line and you write 1 under. So because the 1 is negative, the run is you're going to go down. Why? Because 1 is negative. And for the rise, okay, the rise is negative, so you go down 1 unit. And the run is positive 1, so you're going to move to the right 1 unit. And where are you going to start? At the y-intercept. And what number is added to negative x is 0. So you're going to start at the y-intercept, which is 0. So let me place my dot right there. Okay. So I'm going to then, from the y-intercept, which is at the origin, I am going to go down. I'm following the slope. I'm going to do down 1, and I'm going to move to the right 1. Then I place my dot. I'm going to go down 1 and move to the move to the right 1. Then I place my dot. I go down 1 and move to the right 1, and I place my dot. So you keep doing it, down 1 and to the right 1, then you place your, I think I'm set. Okay, so what am I going to do next? You see that I can only grab this line only up to from positive 2 and to forever. So I have to go back and erase all the other pair I have on the left side of positive 2. Why? I can only grab the line of the function of y equal negative x for all x values greater than 2. So next, let's connect the dot with the ruler, okay? And make sure you only include the arrows on the right side. You cannot include the arrows on the left. Why? There's a restrictions that you cannot pass. So then I need to ask myself, is it going to be a full dot or empty dot when x equal 2? Because there is no line under inequality, the x cannot be equal to 2. So I am going to draw an empty dot like that. Okay. So, and you're done with graphing the piecewise defined function. Okay, so I am going to do more example, and I hope this one was helpful. Okay, so see you into the next video. Bye bye.